Hi there. I wanted to show you a technique to calculate the area under a graph. And we can start with a coordinate system. You have a y-axis and you have an x-axis. Suppose we have 2 points, 2 and 4 on the x-axis, and we have 3 on the y-axis. Then we have a function that says as for every value of x we have 3 on y. Then we have a straight line like this. I've chosen this for it to be easy to see what we do. So you have a value on y that is 3 all the time, and we want to calculate an area between the value 2 and 4. That's what we want to do. So the function here of x is 3. That's this line. And we can think about this as 2 areas. You have a big area that is from 0 to 4, and you have a small area that is from 0 to 2. And to get this area that we want, you can take the big area and subtract the small area. So we want to calculate this area, and we want to calculate this area and take it away from the big area. Then we get this area that we want. We can call it A. So the technique is to take the big area and subtract the small area. And for this we can use a technique that calls integration. And we need a symbol for that. We have this symbol, and we have an under value and an upper value that defines where we want to calculate the area on the x-axis. So we want to calculate the area from 2 to 4. So we have 2 there and we have 4 there. We calculate from 2 to 4. And what we want to calculate is the area of this. And the area we could calculate in this way, that we take small pieces one at a time, that we have a height and a base, and the base we can call dx. It's a small piece of the area. If we take dx, we have a small piece that is a rectangle, and if we sum all of the rectangles, we get the area. That's the idea. So we have this, and we take the function is 3, and we want to calculate the area, so we take the height, multiply it with the base dx, then we get the area. Now we have defined our problem. So now it's time to calculate. This step you have to know some about derivatives and antiderivatives to understand. So you must read some about this, but if you haven't, I hope you can trust me so we can continue. So I say the antiderivatives to 3, the function 3, is 3x. And we use brackets to show that we have moved from the function value to the antiderivatives. And we move the the numbers, the under number and the upper number, we just write it down, so we don't calculate anything there. Now we have to do some steps. Now we have our mathematics to calculate the big area minus the small area. So that's what we do here. So this formula, means that the x value, if you change the x value to 4, then you get the upper area, and if you change x value to 2, then you get the small rectangle, the under area. So we do that. We take this one and subtract it with this one. So we change x to 4, 3 times 4 minus 3 times 2. Then we get 3 times 4 is 12 minus 3 times 2 is 6, and we end up with 6 area units. That's our result. And 6 is exactly the half of 12. So if you look at this one, if the big one is 12, half of it must be 6. So it's pretty much right. So that's a technique you can use to calculate an area under a graph. And this is a very simple example. I've made it like this so that you have the opportunity to understand it. But it's no difference in the technique when you have a line that's not straight. It could be a function, and like this or like this, and you can calculate it as easy as this. But you have to understand the technique of antiderivatives. This is the hardest step from there to there. Thank you.